Namaskar. Today I am going to give a talk on biodiesel. The content of the topic is introduction, sources of biodiesel, production of biodiesel, properties of biodiesel, global biodiesel policies, and finally the conclusions. The biodiesel refers to a vegetable oil or animal fat based diesel fuel consisting of long chain alkyl like methyl, ethyl or propyl esters. Biodiesel is typically made by chemically reacting lipids, example vegetable oil, animal fat with an alcohol producing fatty acid esters. Biodiesel is meant to be used in standard diesel engines. It is thus a distinct from the vegetable and waste oils. These run in fuel converted diesel engines. Biodiesels can be used alone or it can be blended with petrodiesel in any proportions. Biodiesel can also be used as a low carbon alternative to heating oils. Biodiesel is a diesel like fuel derived from vegetable oil or other renewable resources. Biodiesel is made by combining the vegetable oil with alcohol. It is done in the presence of catalyst through a process called Transesterification. Most of the world uses a system known as the B factor to state the amount of biodiesel in any fuel mix. For example, 100% biodiesel is referred to as B100. Another example, if it is 20% biodiesel with 80% petrodiesel is labeled as B20. 5% biodiesel with 95% petrodiesel is labeled as B5. Then 2% biodiesel with 98% of petrodiesel is labeled B2. The blends of 20% biodiesel and lower level can be used in diesel equipment with no or only a minor modifications. Although the certain manufacturers do not extend warranty if equipment is damaged by these blends. The B6 and B20 blends are covered by the ASTM, that is American Standard for Testing Materials. The biodiesel can also be used in its pure form, that is B100. It may require a certain modifications in the engine to avoid maintenance and performance problems. With a staggering economy, climbing gas prices, the global climate change, some researchers are exploring sources other than petroleum for fuel. Organic matter is one such sources that materials like corn and soybeans have oil extracts that can be converted into a ethanol or biodiesel. These and many more sustainable than petroleum biodiesel or biofuel can be regrown and remain productive with less negative impact on our ecosystem. Biodiesel can be made from various sources. There are 10 important sources have been listed. For biofuels or biodiesels listed here have been potential or considered to be more potential when they are used in combination with other biofuels. This will go to a long way in meeting our energy requirements for future. One of the important resources is cellulose. Cellulose is considered to be one of the best source for biodiesel. The cellulose is basically fiber. It can be found in things ranging from switchgrass to trees such as hybrid poplar or willows. Even materials from other industrials like corn stalks after harvest could be used for cellulose fuels. The cellulose is so abundant, can be continuously regrown and harvested. It is one of the cleanest burning material and rated number 1 fuel. Algal oil. The algae are grown in water. Some common forms of algae are seaweed and pond scum. Algae can store up 50% of their body weight in fat. it is rendered into oil or ethanol production. They also grow amazingly fast, so it is to crop that could meet the high demands for energy over the long term. Corn. The corn is used for fuel, could have been someone's dinner. It is explained that even once the corn oil has been extracted for ethanol, there is still, it can be used or it can be fed into for animals. Much like sugarcane, corn is one of the best options we have available now. Soya. The soya beans, the soya has been a popular biofuel for several years. In a process called Transesterification, producers squeeze the oil from its seeds. The produced product is used as biodiesel and jet fuel. It is a relatively easy and inexpensive rendering processes. Sugarcane. In the world of biofuel production, today sugarcane is second to corn as the most widely used. This will likely to change in the coming decades. The sugarcane grows in warm parts of the world in abundance. It has helped countries like Brazil to become the energy independent. Camelina or Jatropha. The camelina or Jatropha are both plant-based fuel sources that are found all over the world. These flowering plants have an advantage over other sea-based fuels like soya because it can be grown in very dry areas, while the Jatropha has the added benefits of making even poor soil into more fertile over time. Rapeseed. Better known as canola oil, rapeseed oil is rendered from a plant found commonly throughout Canada and the United States. Similar to soya, it is cheap and easy to produce and burns for cleaner than petroleum. It makes quick fix to energy problems. Methane. In Stockholm, Sweden, an entire fleet of buses is already running on the natural gas methane. The resource has been gaining popularity as a biofuel in recent time. Microorganisms decomposing organic matter like food, compost and other landfill materials create methane. As it is already being produced in dumps around the world, methane is considered a possible solution. Animal fat. The pigs, chickens and cows all are fairly common in everyday life. They could have uncommon potential for biofuel. Leftover fat from the animal, good products, then produces oil and then used as a fuel for cars and trucks. Paper waste. A recycled paper or paper sludge from production and even sawdust from the early processing stages of paper have contributed as possible sources of biofuel. Biodiesel production is the process of producing the biofuel or biodiesel through the chemical reactions transesterification and esterification. This involves the vegetable or animal fats and oils being reacted with the short chain alcohols. Feedstock pretreatment. The common feedstock used in biodiesel production includes yellow grease, that is recycled vegetable oil, that is virgin, that is vegetable oil, and tallow. The recycled oil is processed to remove the impurities from cooking storage and from cooking and handling such as dirt, charred food and water. The virgin oils are refined but not to be food grade level. So, degumming to remove the phospholipids and other plant matter is common, though the refinement process is very easy. Product of purification. The product of the reaction includes not only biodiesel but also byproducts. They are soap, glycerol, excess alcohol and trace amounts of water. All these products or byproducts must be removed to meet the standards. The order of removal is process dependent. One of the important process dependent is the density of glycerol is greater than that of biodiesel. This property difference is exploited to separate the bulk of the glycerol co-product or byproduct. Residual methanol is typically recovered by distillation and reused. Soaps can be removed and converted into acids. Residual water is also removed from the fuel. Transesterification. The animal and plant fats and oils are composed of triglycerides, which are acids, and the trihydric alcohol glycerol. In the transesterification process, the alcohol is deprotonated with a base to make it to a stronger nucleophile using ethanol and methanols. It can be seen the reaction has no other inputs, that the triglyceride and the alcohol remain same. Under the normal conditions, these reactions will proceed either exceedingly slow or not at all. So, yields as well as the catalysts like acids and base are used to speed the reaction. It is important to note that the acid or base is not consumed by the transesterification reactions. Thus, they are not reactant but the catalysts. Common catalysts for transesterification includes the sodium hydroxide, potassium hydroxide and sodium methoxide. Almost all biodiesel is produced from virgin vegetable oils using the base catalyzed techniques. As it is the most economical process for treating virgin vegetables oils, it requires only low temperature and pressure to produce over 98% of conversion yields. Triglycerides. Triglycerides are reacted with an alcohol such as ethanol to give a ethyl esters of fatty acids and glycerol. The reactions R1, R2 and R3, this all belongs to alkyl group. Then alcohol reacts with the fatty acids to form the monoalkyl ester, that is biodiesel, and a crude glycerol. The biodiesel is a liquid which varies in color between golden and dark brown depending on the production feedstock. It is slightly miscible with water. It has a high boiling point and low vapor pressure. The flashpoint of biodiesel is more than 130 degree centigrade to 260 degree Fahrenheit, is significantly highest than that of petroleum diesel, that is about 64 degree centigrade to 147 degree Fahrenheit, or a gasoline which is minus 45 to minus 52 degree Fahrenheit. Biodiesel has a density of plus or minus 0.88 grams per centimeter cube, that is higher than the petrol diesel, it is 0.85 grams per centimeter cube. The biodiesel has virtually no sulfur content. It is often used as an additive to ultra low sulfur diesel, that is ULSD. It is in the form of a fuel or to aid with a lubrications. It has the sulfur compounds in petrol diesel provide the lubricity. The calorific value of biodiesel is about 37.27 mJ per kg. This is 9% lower than the regular number 2, that is petrol diesel. The variations in biodiesel energy density is more dependent on the feedstock used than the petroleum process or production process. Still, these variations are lesser than the petrol diesel. It has been claimed that the biodiesel gives better lubricity and complete the combustion, thus increases the engine energy output. The biodiesel has better lubricating properties. It has higher cetane rating compared to today's low sulfur diesel fuels. Biodiesel addition reduces the fuel system where and in low levels in high pressure systems. This increases the life of the fuel injection equipment that relies on the fuel for the lubrications or for its lubrications. Depending on the engine, this might include a high pressure and the high pressure injection pumps, pump injectors and fuel injectors. Production statistics. The biodiesel industry has steadily grown over the past decade in every state in the country. The industry reached a key milestones by producing 1.1 billion gallons in 2011. It is the first EPA, that is Environmental Pollution Act or Environmental Pollution Act, that designated advanced biofuel to reach 1 billion gallons of animal productions. The industry repeated that volume in 2012 by again producing 1.1 billion gallons. In both the years, the biodiesel productions exceeded the requirements under the Renewable Fuel Standards, that is RFS. Many countries around the world are involved in the growing and production of biofuels. The biodiesel or biofuels serves as an alternative energy source to fossil fuels and oil. To foster the biofuel industry, the government have implemented legislations and laws as incentive to reduce the oil. To increase the use of renewable energies, many countries have their own independent policies regarding the taxation and rebate of biodiesel uses, and they can import and productions also. Individual provinces also have specific legislative measures in regards to biofuel or biodiesel uses and the productions. The volumetric ethanol excise tax credit, that is VEETC, was the main source of financial support for biofuel in United States. The European Union is the greatest producer of biodiesel, with France and Germany being the top producers. Environmental impacts or environmental effects. The surge of interest in biodiesel has highlighted a number of environmental effects associated with its use. This includes the reduction in greenhouse gas emissions, deforestation, pollution and the rate of biodegradation. According to the Environmental Protection Act, that is EPA, Renewable Fuel Standards Program Regulatory Impact Analysis, the diesel or biodiesel from soya oil results on average of 57% reduction in greenhouse gases compared to petroleum diesel, whereas in 2000 biodiesel became the only alternative fuel in the country to have successfully completed the EPA required Tier, that is 1 and Tier 2 classes or Tier 2 cities. To overcome the health effects, as per the Clean Air Act, this test conclusively demonstrates the significant reduction of all regulated emissions, and this shows the biodiesel does not pose a threat to human health. Environmental benefits. So, the biodiesel contains no sulfur or aromatics. The use of biodiesel in a conventional diesel engine results in substantial reduction of unburned hydrocarbons or even carbon monoxide or even particulate matters. An US Department of Energy study showed that the production and use of biodiesel compared to petroleum diesel reduces carbon dioxide into 78.5% emissions. Then biodiesel as a positive energy, and for every unit of energy needed to produce a gallon of biodiesel is 3.24 units of energy or gain. Energy security benefits. The agricultural commodity prices approaching low records, the petroleum prices approaching high records. It is clear that the use of the vegetable oil enhances our energy security. The biodiesel can be manufactured using the existing industrial production capacity and with available conventional equipment, and it provides a substantial opportunity for immediately addressing our energy security issues. Economic benefits. The increased utilization of renewable biofuel results in significant microeconomic benefits to both the urban and rural sectors and the balance of trade. The demand would boost total crop cash receipts by 5.2 billion dollars cumulatively by 2010. That is resulting in an average net farm income increases by $300 millions per year. The price for bushel of soybeans would be increased by an average of $0.17 annually during the 10 years period. Quality benefits. The biodiesel is registered as a fuel and fuel additive with the EPA, that is Environmental Pollution Act. This meets the clean diesel standards established by California Air Resource Board, that is CARB. B100, that is 100% biodiesel, has been designated as an alternative fuel by the US Department of Energy and US Department of Transportation. The National Biodiesel Board has formed the National Biodiesel Accreditation Commissions, that is NBAC, National Biodiesel Accreditation Commission. The biodiesel marketed by these companies meet the ASTM standard for biodiesel, that is American Standard for Testing Materials. So, they have required or they can meet the requirement according to their ASTM standards for biodiesels. In addition to being a domestically produced renewable alternative fuel for diesel engines, the biodiesel has positive performances attributes such as octane, high fuel lubricity and high oxygen content. This makes it a preferred blending stock with the future ultra clean diesel. In some poor countries, the rising price of vegetable oil is causing problems. Some propose that the fuel made from non-edible oils such as camelina, jatropha or seashore mallow produces a very low yields. The farmers may switch from producing food crops into biofuel crops to make more money, and even if the new crop are not edible, the law of supply and demand predicts if the fewer farmers are producing food, the price of the food will rise. Some have pointed out that there are some poor farmers and poor countries that are making more money because of the higher price of vegetable oils. Let us come into the advantages of biodiesel or biofuels. There are no global mandates or specific measures to make biodiesel a requirement. However, many governments are actively encouraging the use of biodiesel blends and have issued a mandates of their own. In most instances, the producers are struggling to meet the demands of these mandates. Examples of biodiesel blend mandates in force includes the Colombia, that is 20% by 2014, Germany it is again 12% around 2017, Australia is 5% by 2014, India is 5% by 2014 and again Canada is 2% by 2013. There is a growing pressure around the world for countries to conform to minimum biodiesel blend mandates. The pioneer work is being done by those governments with green mandates from their electorate. It is cleaner burning, renewable fuel source. The availability and usage will continue to increase. Then advantages of biodiesel over petroleum diesels. If you see the scenario or the world scenario or a global scenario, you can see the lot of advantages when compared the biodiesel when compared to a petroleum diesel. We have been facing lot of acute scarcities of petroleum diesel. There is no other alternative. We have to switch over to the biodiesel, which are considered to be cheaper when compared to petroleum diesel. The biodiesel is simple to use, biodegradable, non-toxic and essentially free from sulfur and aromatics. It can be used in most diesel engines, especially newer ones. This emits less air pollutants and greenhouse gases other than nitrogen oxides. It is safer to handle and has virtually the same energy efficiency as petroleum diesel. In addition, it has lubricity benefits that fossil fuels do not. Biodiesel blends as low as B2 have been found to be significantly used or reduce the amount of toxic carbon based emissions. With the soaring price of petroleum based petroproducts, biodiesel is becoming an increasingly affordable option relative to petroleum diesel. The use of biodiesel helps reduce the dependence on finite fossil fuels reserves. It can be used as an alternative energy sources if it is relatively easy to process and available with machines like Biofuel, etc. To all communities, from rural communities in developing nations to urban in developed countries, the scientific research confirms that biodiesel exhausts a less harmful impact on human health than petroleum diesel fuels. Biodiesel emissions have decreased the level of hydrocarbons and nutritive compounds that have been identified as potential cancer causing compounds. One of the major advantages is that it can be used in existing diesel engines with no modifications required in most instances, with minimal or no loss of operating performances. In terms of fuel efficiency, biodiesel has virtually the same miles per gallon, that is MPG rating as petroleum diesel, or can be used or can be considered or can be compared. Biodiesel is the only alternative fuel for heavyweight vehicles requiring no special dispensing and storage equipment. It blends easily and stays blended with petroleum diesel. It can be stored and dispensed wherever the diesel is stored or sold. In terms of combustibility and safety, the biodiesel has a very high flash point, that is 300° Fahrenheit, making it one of the safest of all alternative fuels. It is the only alternative fuel than any actually extend engine life because of its superior lubricating and cleansing properties. On the production side, biodiesel is effectively carbon neutral. Finally, the biodiesel is the only renewable alternative diesel fuel that actually reduces the major greenhouse gas components in the atmosphere. So, before going to the conclusions, so if you go through the advantages and disadvantages of biodiesel when compared to petroleum diesel, so definitely it is very cheaper and it is having less component or less greenhouse gas components in the atmospheres. Compared to the other alternative fuels, biodiesel has several unique features and qualities. Unlike any other alternative fuels, it has successfully passed through all the health effects testing requirements. It meets the standard of 1990 Clean Air Act amendments, that is CAAA, that is the world will face a severe energy crisis within 1 or 2 decades. All the vehicles may become a waste if we do not find an alternative fuel to their vehicles. Biodiesel is one of the best possible sources. If there is a will, there will be a way to use a biodiesel and survive for centuries. Thank you.